sometimes people like to use these box diagrams. You use them at first and you kind of get a visual for it. And remember, some printers are real lazy. They don't draw the whole box. They'll just draw the bottom line. But they call them box diagrams. Therefore, I like to do that. Okay, and some are so cheap, they put them all flat and they don't show you that these are higher in energy. And I like that visual too. Okay, we just start filling here. Remember the half arrow up and half arrow down. What was that trying to show? You got a half arrow up for the first guy and a half arrow down for the other. Okay, they're paired electrons. How are they paired? We think they spin in opposite directions, and that allows them to tolerate each other. So, if you had to describe this for me, let's go up through here. Bruce, tell me what to do.
Up and down, up and down, up and down.
Okay, now, he said up and down, which, who knows once I write it all, but in reality, if it's going in one at a time, let's say it's going in one.
Okay, then you go 3 ups and then 3 downs.
You got it. And whose rule were you following?
Oh, that guy's name, I can't remember.
Okay. Hund's.
Hund's, yeah.
H-U-N-D. Hund's rule. Okay, tell me more.
Up and down, up, 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 down, down, down. 1 up, and then 5 ups.
Okay, great. Al has a lot of practice of dragging arrows around for you, which will give you plenty of practice if you need it. Okay, once you get this, now see, this is really an alternative to this, or this, or this. Okay, now, we did that. When you have this picture, then how many unpaired electrons does chromium have? If you know it's an exception, how many unpaired electrons here? Sarah, what would you say? 6. Okay, now did I use the words for you, paramagnetic and diamagnetic last time? I don't think I did. That is what section 20 is about. And here's the definitions. We don't use the terms a whole bunch, at least in this course. Paramagnetic means it's attracted into a magnetic field. Whereas if something is diamagnetic, it is not attracted into a magnetic field. So here's the bottom line that's important for us. If you have any unpaired electrons, you're going to be attracted into a magnetic field, and so we say, aha, this is paramagnetic. How are you going to remember that? Para, like let's see, paramedic type thing, you're with the doctor. Okay, so paramagnetic, you're with the magnetic field. Why are you attracted? You've got unpaired electrons. So we have 6 unpaired electrons. The more unpaired electrons you have, the stronger the attraction into the magnetic field. That's how they really came up with the idea something weird is going on with chromium. Because if we didn't know that business, that if you can have a half full shell, it's going to happen. Let me write this. Don't change yours. What Russell originally gave me, he gave me this. Okay, and that's before we knew about exceptions. How many unpaired do you see now? 4. It's still paramagnetic, but it's stronger than just having 4, and so they had to come up with some explanation, since you don't actually see the electrons. If you try to measure them in a lot of ways, you're blasting them out. That's, I think, what I mentioned about shooting Bruce last time. Okay, so this one was so paramagnetic, they had to come up with some reason. How could it possibly have 6 unpaired? Okay, so we got 6 unpaired if we know it's an exception. Now, let's go back. Chromium. We want to talk about families, we want to talk about periods, and then we talk about, is it a metal, a non-metal, or a metalloid? So, chromium. Look up there on the periodic table, and what family, Allison? 6B. Okay, and all you have to look at is what's up above them. And so that's your family name, and of course the families are vertical. Then, if I said, what period is that in? Eddie, what would you tell me for period?
4th.
4th, good. Remember the idea of period? is just horizontal. You don't take any fancy dips, and sometimes that's confusing for people because they get confused about the period here, which is a real simplistic idea, versus electron configuration, because you know this may be 4s, but you know that's 3d, but when you talk period, it's just straight across.
So then after 3D, we go back to 4p6.
If we had more electrons, that's where we'd head. Okay, after we fill 3d.
Yeah.
Okay. Now, just an aside, my husband's an optometrist. If you've ever gone to an optometrist and had your eyes checked, do they ever run that little test on your eyes where they say, is it the vertical is darker or is the horizontal darker? Have any of you been tested like that? They put this little thing on your face? Okay, if your optometrist or ophthalmologist said to you, is the vertical darker, is the horizontal darker, that is a compliment. Because over at the School of Optometry, they teach them. The general public doesn't know those two words. And if you say, is it vertical or horizontal, and they don't know it, they'll be embarrassed. So if your optometrist is saying up and down or the sideways, then that's kind of a put down because they don't think you're educated enough to know those two words. So, or maybe they just have a general policy. They'll say up and down and sideways for everybody. All right, now, let's do one more here. Is it a metal, a non-metal, or a metalloid? And that's where we have this handy-dandy red line there. So, Nicole, in this row, metal, non-metal, or metalloid?
Non-metal.
Non-metal? What's your line? The red line here?
For chromium?
Yeah, we did talk about the Alpo line, didn't we? Okay, here's the Alpo line. A-L, P-O, and Ruben put that red tape on there for you. Okay, if you are to the left and or down, what are you, anybody?
Metal.
You're a metal. Now, how are you going to remember that? Think of some metals you know and love. Gold and silver. You think of those as metals, and they are on that side of the line. Now, for a chemist, we don't just say metals are nice, you know, they're shiny, they conduct electricity, they conduct heat generally. That actually, to be a metal, they tend to lose electrons and become what? Cations or anions? You lose electrons. Cations, good. Okay, our nonmetals are up here to the right and above, and they have just the opposite characteristics. So the way a scientist defines a nonmetal, not that it's dull or sometimes brittle, that they define it as they tend to gain electrons, and therefore they become anions. Exactly. The guys on the line are kind of in between. Metalloid means metal-like. Now there is discrepancy, and if you're in the OWL stuff, they're going to want you to say aluminum is a metal. Although technically up here, because it touches the line, it's a metalloid. But there is differing opinions about that.
Is it everything that touches line on both sides? Or is it
Yes, both sides. Good question. So, silicon is a metalloid, germanium is a metalloid, arsenic, antimony, if it touches the line, either side. Even though it says metalloid, it's crossing the line. Andrew?
Going back to the box diagram, say there were
Yeah, titanium.
titanium. Yeah. Okay, say if we're titanium, so then would it be up, down for the 4S?
Yeah,
And
up, down
then-
for the 4s, and then,
And then it would just be up, up?
yep.
And so how many unpaired electrons?
How
would
many
that?
do you think?
Would it be 2,
Yeah.
or would it be, okay.
2.
I wasn't
Because-
sure if a box was left blank, if that counted as one.
It's, no,
Or just.
it's an empty space.
Okay.
It's just a volume in space, and nobody's there right now.
Okay, so basically try to fill the room, or,
Yeah, so
and
Yeah.
then the second round you try to.
Hund's
figure out-
rule, yeah. You go
Okay.
1, 2, 3, 4, 5, double back. Hund's rule. Remember the Electron Hotel story? He wants a private room.
Okay.
Okay, now we've reviewed all of that stuff. We've reviewed that stuff, and I would say in this chapter, to me, 4-18 is the most important. We talked about orbitals and their shapes, and we talked about using the periodic table, but I shouldn't be starring all these because I wanted to indicate that is probably the biggie, and that's important, that's really kind of all together, you get the electron configuration, where you have those three levels. You're talking about the major level, then you're talking about the sub-level, and then finally we get down onto the orbital level, and that's our last level. Then we talked just very, very briefly, paramagnetic, you're attracted into a magnetic field, so you must have unpaired electrons, or diamagnetic, meaning no unpaired electrons, so they put you in a magnetic field and nothing happens. And now we're ready for the last thing in this chapter. And in the chapter, you notice I'm way out of order here, the authors do this part first. And this part is very theoretical in comparison to the electron configuration. To me, the electron configuration stuff is nice, concrete stuff. You go 1s2, 2s2, once you get the hang of it, no big deal. Okay, quantum numbers first. Here, let's talk about what quantized means. If something is quantized, we talk about